welcome to the Algorithm channel. Today we are learning about Eulerian and Non-Eulerian graphs. Let's talk about what a graph is. A graph is made for two parts, vertex and edge. Vertices are points like dots and edges are lines that connect these points. For example, this graph has 2 points labeled A, B, C and D. They are connected by 5 lines. Each line is an edge. Graphs are everywhere. Maps, roads, networks or even social media connections. Understanding graphs helps us solve real problems like planning routes or visiting every state without repeating. Next, let's talk about vertex degree. The degree of a vertex is a number of edges connected to it. For example, if a vertex has 2 edges, its degree is 2. If it has 3 edges, its degree is 3. We also call vertices with even degrees even vertices like 2, 4 or 6. Vertices with odd degrees like 1, 3 or 5 are odd vertices. Knowing the degrees of each vertex is very important to understand Eulerian graphs. For example, here vertex A and C has 3 edges, that's odd. Vertex B and D has 2 edges, that's even. Now, what is an Eulerian path? An Eulerian path is a path in a graph that visits every edge exactly once. You can start and end at different vertices. You don't always need to visit every vertex, but you do go through every line. Think of it like this. You want to draw a figure with a pen without lifting it and without drawing the same line twice. That is an Eulerian path. For example, in this graph, we begin at A and follow the edges in order A to B, B to C, C to D, D back to A, and finally A to C. So every connection is used once without repeating, ending at C. Every edge is used only once. This is an Eulerian path. An Eulerian circuit is a special type of Eulerian path. It also uses every edge exactly once, but it must start and end at the same vertex. So, it forms a complete loop. It's like working through every street in your neighborhood without repeating and then coming back home. For example, in this graph, we can start at A, move to B, then C, then D, and finally return to A, using each degree exactly once and coming back to where we start, A, B, C, D, A. This is an Eulerian circuit. And here, a graph is called Eulerian if it has Eulerian circuit. That means you can start anywhere, work through every edge exactly once, and return to the starting point. The rule is the graph must be connected, meaning there is a way to reach every vertex, and every vertex must have an even degree. These are the conditions that we discussed earlier for an Eulerian graph to exist. So, let's go straight to the example. Here we have 4 vertices A, B, C and D. Each has 4 edges, even degree, and all vertices are connected. That means this graph is Eulerian. So, you can start at any vertex, follow the edge without repeating and return to where you start. Next is semi-Eulerian graphs. These graphs have an Eulerian path but not circuit. That happens when exactly two vertices have odd degrees and the rest are even. The graph must be connected. In this example, vertex A has 2 edges and vertex D has 3 edges. B and C have even degrees, so the Eulerian path must start at one odd vertex A and end at the other odd vertex D. You cannot make a loop here because you start at one odd vertex and end at the other. Finally, non-Eulerian graphs are graphs where you cannot have an Eulerian path or circuit. This happens if the graph is connected or has more than two vertices with odd degrees. Look at this example. All four vertices A, B, C, D have odd degrees. That means you cannot work through every edge only once, no matter where you start. Now we are going to summarize what we did today. First, Eulerian graph has Eulerian circuit, all vertices even, start and end at the same vertex. The second one is semi-Eulerian graph, has only Eulerian path, exactly two vertices odd, start at one odd vertex, end at the other. The third one is non-Eulerian graph. No Eulerian path or circuit, more than two odd vertices or disconnected. And that's it. Now you know how to identify Eulerian, semi-Eulerian and non-Eulerian graphs. I hope this video was easy to understand. If you found this video helpful, like this video, subscribe my YouTube channel and turn on the bell icon. Thank you for watching. See you in the next video.